session. Aisha, bache, why you have joined late?
Sorry, mom. I was trained.
Okay. And you are not submitting your homework.
Yeah, mom, I have to catch up. I still have the recorded lectures to go through. I'll
Okay, just
submit it by next
relax.
week.
Yeah.
Yeah.
Okay. Okay, uh, so we have completed till here. We have started your new chapter, your equilibrium chapter, and we have discussed the relationship between the Kp and Kc in the previous class. Till here. We have derived the equation. We have derived this equation between the relationship between the Kp and Kc. Right? And this formula is very, very important. Kp is equals to Kc into RT raised to the power delta Ng. And what is delta Ng over here? So delta Ng is the change in the number of moles. The change in the number of moles, which is given by the NP, the number of moles of gases of product minus the number of moles of gases of reactant. Okay, so product minus reactant. So it will give you a delta Ng. Now, okay. So in your note part, you can write down this at equilibrium concentration of each reactant and product become constant. At equilibrium concentration, the reactant and product concentration basically it become constant. For example, PCl5, which is in gaseous form. So it will dissociate to form PCl3 plus Cl2. Okay, all are in gaseous phase. You can see over here, all are in gaseous phase. So when you plot the graph between the concentration versus time, right? So here, according to this, PCl5, right? PCl5, it is giving you PCl3 plus Cl2, right? So this is your reactant, okay? Reactant, and this is your product. Product is your PCl3 plus your Cl2. This is your product. And we know that when in a chemical reaction, right? So this PCl5 is dissociating to form PCl3 plus Cl2, right? So here the concentration of this reactant will decrease. First क्या होगा? The concentration of the PCl5 will decrease, and the constant when it decreases, right? So it will form the PCl3 plus Cl2. Means the concentration of the product, उसका graph कैसा होगा? Just an increment type of graph. So here you can see this is the graph of PCl5, which is a reactant. So the concentration of reactant it is decreasing, right? And after some time at this point, okay, at this point they are like they are aligned over here, and after some time they become constant. Okay, so after equilibrium, at equilibrium, the concentration of PCl5 and the PCl3 and PCl2 concentration they become constant. See this reaction. See this data over here. Okay, let me zoom. Yeah, see this. This is a concentration versus time graph. Concentration versus time graph. Time graph. Okay, so on the y-axis, we are just taking the concentration. On the x-axis, we are just taking the time. Now, when we talk about first we will talk about the reactant. What is reactant over here? PCl5, right? So PCl5, iska kya ho raha hai? The concentration of the PCl5, it decreases, right? And after some time, it becomes constant. Now, on the other hand, the concentration of PCl3 and the concentration of Cl2, okay, which is a product. These two are the products in this reaction. So the concentration of PCl3 is this last line, this, okay, and the concentration of Cl2, this. You can see the concentration has been increasing. Okay, this is an increasing type of graph. The PCl3 की concentration क्या हो रही है? Increase हो रही है. Same as for the Cl2. Okay, for the Cl2 also the concentration increases. And after this time, okay, after this time the concentration become constant, right? So at equilibrium, when the reaction reach at equilibrium, right, the concentration of product and reactant become constant. And that is the ideal graph of equilibrium. Okay, when some reaction is in equilibrium, it will show this type of graph, concentration versus time graph. Right. So for the reactant, the concentration will decrease, and after some time it will be constant. And for the product, the reaction, the concentration will increase, and after some time it will become constant, right? So this is the ideal graph for the equilibrium. When the reaction, some reaction is in equilibrium, so it is the ideal graph for the concentration versus time. Clear to everyone?
Yes, ma'am.
Yeah, mom.
Okay. So first try to understand, then I will give you time to note down. Now see, suppose this is your question. The correct option is being marked over here, no issue. Let's understand the question. So question is, which of the following graph represent the equilibrium for this reaction? N2 plus 3H2, okay? In the equilibrium, it will give you 2NH3, right? So you have to check out which option is representing the correct equilibrium graph, okay? So it is again a concentration versus time graph, concentration versus time graph. Okay, time graph. Okay, now just analyze this question and let me know which option will be correct. And you will give me the answer, reason also. You will explain me the reason also. This is N2, this is the reaction. This is the reaction. And you have to check which graph is correct representation for the equilibrium, concentration versus time graph. N2 plus 3H2. It will give you 2NH3, ammonia. Just analyze all the graph A, B, C, D. Okay, so let me ask you one by one. Yes, Sanidhi, tell me, is A graph is correct representation of the equilibrium for this reaction?
Yes, mom.
Okay. Yes, Neha, is she correct?
Yes, mom.
Are you sure? She is okay.
Yeah.
Let's move to the next one. Aman, tell me, is A option correct?
Uh, yes, I think it's correct.
Zunaira,
Yes, ma'am. I think it's correct because all the three are like constant, right? So that's why.
so you have to check all the three are constant. What I said, you don't catch my point. Okay, next one, Aisha.
Mom?
Tell me if A is correct representation of equilibrium, the equilibrium
Not sure.
graph concentration. Not sure?
Not sure.
Zanab?
Ma'am, even I'm not sure. Is it
Okay,
C?
let me explain. Let me explain it to you. What I said, the reactant, the concentration of reactant will decrease, right? The concentration of reactant will decrease and the concentration of product will increase. And after some time, the concentration of reactant as well as the product become constant. So you have to check according to this equation. So N2 plus 3H2. What is this? This is your reactant. And what is this? This is your product, right? So for N2 and H2, the concentration should be decreased, just like that, decreasing order mein hona chahiye. But here, you all said that A is correct. Okay, but A is wrong. A is not the correct representation.
C.
Why? Let me explain it to you. See, this is ammonia. You should know how to read the graph. This is a concentration versus time graph. So you should know how to read the graph. So see this. This is NH3, ammonia. What is this? This is product. According to my concept, the concentration of product will increase. But here it is decreasing. Here the concentration of ammonia is decreasing, right? Which is wrong. Getting my point or not?
Yes.
Yes, ma'am.
So, and for N2 and H2, because it's a reactant, So the concentration of these two, N2 and H2, will decrease. Okay. For product, it will increase, and for the reactant, it will decrease. So here it's just opposite. It's just opposite. The N2 and H2 concentration is increasing, and for the product, which is ammonia, is decreasing, which is wrong, right? Now, see the B graph. B graph. So N2, for N2 only, the graph, the concentration is decreasing. But for H2, it's increasing, which is wrong, right? So this is again wrong graph. Now see the ideal, as I told you, this one, which I told here, this one is the ideal graph. This one is the ideal graph. For the reactant, what is reactant over here? PCl5. So PCl5 ke the concentration is decreasing. Okay, and for the product, which is PCl3 and Cl2, the concentration is increasing, and after some time, after this point, the concentration becomes constant. Means the reaction, now the reaction is in equilibrium. Why it is in equilibrium? Because the concentration of product as well as the reactant becomes constant, right? So see, is the C graph is ideal graph? Yes, C graph is ideal graph. Why? Because you can see according to the reaction, N2 and H2 are the reactant, right? So for the reactant, we know that the concentration will decrease. So here for N2 and H2, the concentration is decreasing. See, first it starts from here, okay? It decreases, and after some time it becomes constant. For H2 also, okay, it decreases, and after some time it becomes constant, right? For NH3, which is a product, and we know that for the product the concentration increases. So concentration, okay, first यहाँ पे क्या था? It was 0, and it starts, okay, according to the time, it starts and it increases, and after some time, after this point, it becomes constant. So this is the ideal graph. This is the correct representation of the equilibrium graph. Okay, concentration versus time graph. Now check this D graph. So here for H2 and N2, the concentration increases, right? And for NH3, it decreases, which is again wrong. Okay, so these three graphs are wrong. The correct representation of this equilibrium graph, concentration versus time, is C. Is it clear to everyone?
Yeah,
Yes.
mom.
Yeah, mom.
Okay, now you guys will not do the same mistake. Okay, this is the ideal graph. Okay, just remember for the reactant, the concentration will decrease, and for the product, it will increase. And after some time, it will become constant. So, so you can say that this reaction now it is in equilibrium. Okay, now you can write it down. Now note it down, then we will do some questions. Done, written?
No, mom, one sec.
Okay, so written everyone?
Yeah, mom.
Okay. Okay, now see this. So we have this equation. Kp is equals to Kc into RT raised to the power delta Ng. Now, what if we have three cases? If Ng, delta Ng is greater than 0, means the value of delta Ng is positive, right? Second case is when the value of delta Ng is equals to 0. Okay, what is delta Ng? You should know delta Ng is the number of moles of the change in the number of moles of gases. Delta Ng, if it is less than 0. Okay, then what is the conclusion for that? So when delta Ng is greater than 0, okay, greater than 0, so it means that delta Ng value is positive. Okay, and when it is positive, it is positive when the product has more number of moles. So that's why you have to subtract. What is delta Ng? Delta Ng is the number of moles of gases of product minus number of moles of gases of your reactant, right? So if the product is greater than the reactant, the number of moles of product is greater than the reactant, then only the delta Ng value is your positive. If the delta Ng is less than 0, so what does this mean? That your Ng, the number of moles of gases of reactant is more than that of product. That's why you are just getting the delta Ng value as negative, which is less than 0, right? So for the delta Ng, which is greater than 0, for the positive value of delta Ng, the product has has more moles of gases. Product has more number of moles of gases, right? So for the first case, Kp, if the product has more number of moles of gases, then your Kp is greater than Kc. Kp is always greater than Kc when the delta Ng value is positive. Just remember that. Okay, coming to the second case. When the delta Ng value is 0. When it will be 0? When it will be 0, so let's check it out. When it is 0, it means that product has same number of moles, same moles of gases. Okay, When the product, suppose product has number of mole 1 mole, okay, and the reactant is again the number of mole is 1, so it will be 0. 1 minus 1, it will give you delta Ng value as 0, right? So if the delta Ng value is 0, it means that product has same number of moles of gases than just like the reactant. So here the value of Kp is equals to Kp will be equals to Kc in the second case. Now for the third case, when the delta Ng value is less than 0, okay, means it is negative. So it means that the reactants, or you can write in terms of product also, the product has less number of moles, has less moles of gas than the reactant. Okay, so in this case, Kp will be less than Kc. Okay, just remember these three cases. Okay, again I'm repeating. So if delta Ng value is positive, means greater than 0, it means that product has more moles of gases. Okay, and in this case, Kp is always greater than Kc. For the second case, delta Ng value is 0. When it will be 0, when the product has same number of moles of gases, just like your reactant. Okay, the number of moles of product is equals to the number of moles of reactant. Then only delta Ng value becomes 0. Okay, and in this case, Kp is always equals to Kc. Okay, for the third one, when delta Ng value, the change in the number of moles of gases is less than 0, means negative, right? So here the product has less number of moles of gases than the reactant. And in this case, Kp is less than Kc. Clear to everyone this point?
Yeah, ma'am.
Okay, just quickly write it down. Written everyone?
Yeah, ma'am.
Okay. Okay, so let's do some numerical. So first type 1 numerical, when the data of equilibrium is given. Okay, so they can ask you this type of question when the data of equilibrium is given, right? Means the concentration they will give you and they will ask you to calculate the Kc, Kp, etc. So first question is, what is the Kc for the following equilibrium when equilibrium concentration of each substance is? These are the equilibrium concentration. For SO2, concentration of SO2 is 0.6 molar, concentration of O2 is 0.82 molar, and the concentration of SO3 is 1.9 molar. And this is your reaction. Okay, this is your reaction. 2SO2 plus O2, it will give you 2SO3. Okay, so just remember the reaction should be balanced. Okay, if they don't give you a balanced chemical equation, just check it once in your exam and just balance the chemical equation before doing the numerical problem. So here the concentration are given, right? And we have been asked that constant Kc. We have to check, we have to calculate the Kc, right? So first, using this reaction, just write down the equilibrium equation. Just quickly write it down. What is the equilibrium equation? Okay, so you know very well Kc is equals to, you will write concentration of the product, okay? Concentration of what is product here? SO3. SO3, right? Raised to the power 2. This is the stoichiometric coefficient, so you will raise power 2 upon the concentration of reactant SO2 raised to the power 2, okay, concentration of wood. Okay, so this is according to the equation. According to the reaction, we have written the equation. Now, the data is given. Now it's very simple. The data is given, the concentration of each and every term is given. Now what you're supposed to do, just substitute the concentration term and you will get the answer. Just solve it and you will get the answer. So SO3, the concentration of SO3 is 1.9. 1.9 square. 1.9 square upon what is the concentration of SO2? It's 0.6 square multiplied by O2, it's 0.82. Just calculate it. Okay, and just try to write on the unit also. So 1.9 square. Okay, and its concentration is given. So concentration. Yes, Sanidhi?
Mom, 12.2.
Yes, it's 12.2. Okay, and what is the unit, Sanidhi? So always try to write on the unit also. So for SO3, you will write 1.9 molar into 1.9 molar. So it will become molar square, right? And in the base, right, in the denominator part, it will be molar square and here the molar. Okay. This is only one time O2 concentration. So I have written molar. So this molar square will cancel out. Okay. And this will be remain as it is per molar, right? So 1.9 multiplied by 1.9 upon 0.6 into 0.6 into 0.8, okay, per molar. Just multiply it. So 1.9, 1.99, okay, so it will become 3.61. Okay, and in the denominator, when you multiply these two terms, 0.6 and 0.666 are 36. So 0.36 multiplied by 0.82. Now, when you multiply this 0.36 into 0.82, so it will become like your 0.2952. Just divide these two. Just divide these two and you will get 12.22 something. So you can write approximate value is 12.2 per mole, per molar. That is your constant. That is your Kc value. What is Kc over here? 12.2 per molar. Everyone got the answer?
Yes, ma'am.
Okay, quickly write it down. Okay, let's move to the second question. Okay, so second question is, this is the equation. Okay, 3O2 is get converted into a 2O2, 2O3, sorry. Okay, for above reaction, Kc is found to be this. Now in this question, Kc is given. The Kc value is 3 into 10 raised to the power minus 59. Okay. Now, if the concentration of O2 at equilibrium is this 0.04 molar, then the concentration of O3 in molar will be. There are four options. Okay, A, B, C, or D. Okay, so let's see how to solve this question. So we have this equation, this reaction O3, right? Now always try to write down the Kc equation. What will be the Kc? O3, concentration of O3 raised to the power 2 upon concentration of O2 raised to the power 3, right? It's given. Now the value of Kc is given, already given in the question. So substitute the value. So it's 3.0 into 10 raised to the power minus 59, which is equals to the O3 concentration. Okay, O3 concentration raised to the power 2. Okay, now if the concentration of O2 is already given, right? So just substitute 0.04 molar, right, raised to the power 3. Okay, now you can easily just solve this question. For the O3 concentration, okay, I'm writing here. So O3 raised to the power 2 will become 3 into 10 raised to the power minus 59 multiplied by, it will become 0.04 into okay, just multiply it. Just solve this question and let me know the answer. Okay, just a second. Just change the value. Okay, I'm just changing the value of this 0.4 molar. Okay, take the 0.4 molar. Now quickly solve it. Just substitute the value 0.4 into 0.4 into 0.4. So this 4 fours are 6, 4 fours are 16 and 16 fours are, it will become 0.064, right? So 3 into 10 raised to the power minus 59 multiplied by, so it will become 0.4 fours are 16, 0.64, 0.064, 1, 2, 3, right? Now, how you can write down the 0.064? So you can write 64 multiplied by 10 raised to the power minus 3, right? As in exponential form, so 64 multiplied by 10 raised to the power minus 3. Now just multiply these two terms. So 4 threes are 12, 6 threes are plus, will become 192. 192 multiplied by 10 raised to the power minus 59. When the base is same and power is different, so what you're supposed to do? So 10 raised to the power minus 59, okay, and it become, so basically आप add कर देते हो. When the base is same and the power is different and they are in multiplication form, so the powers will get added, right? So when you add these powers, so it will become, so solve it, 192 into 10 raised to minus 59, plus minus will become minus, and 192 multiplied by 10 raised to the power minus 62. So that is the value of concentration of O3 square. Okay. Now, what you're supposed to do, this is the value of this O3 square. Now, when you take this square on the right side of this equal, so what happens? It will become under root, right? So O3 concentration of O3 will be equals to under root of 192 multiplied by 10 raised to the power minus 62. Now this minus 62, it will become, when it will become 10 raised to the power minus 31. Okay, जब आप इसे bracket से बाहर लाओगे, right? The under root of 10 raised to the power minus 62 will become 10 raised to the power minus 31 multiplied by, what is the under root of 192? So 192 ka under root is 13.85. 13.85 is the under root of 192. Now, in a standard form, we can write this 13.82 as 1.385 into 10 raised to the power. The power will be added, subtracted over here when you are shifting this decimal over here, right? So it will become minus 30. That is the final answer. That is the concentration. What is the concentration of O3 in this equation? So it is 1.385 into 10 raised to the power minus 32. That's the concentration. So now check the options. Yes, so your option D is correct. You can check this. The option D is correct. 1.38 into 10 raised to the power minus 32. It's the correct option. Got this question?
Yeah, ma'am.
Yes, ma'am.
Okay, now just quickly write it down. Written everyone?
Yes.
Yeah, ma'am.
Okay, now the next question is the next question is at a certain temperature and total pressure at a certain temperature and a total pressure and at this pressure 10 raised to the power 5 Pascal. Iodine vapor contains 40% of iodine atoms. Okay, and this is the reaction. So we have to calculate the Kp for the equilibrium. Kp for the equilibrium, or you can say Kp for the equation, this equation. So what happens? So suppose this is your reaction, right? The iodine, I2, okay, which is in molecular form, you can see. This is in gaseous form, right? So it's being converting into atoms, 2 moles of iodine atoms, right? At certain temperature. And here the total pressure is 10 raised to the power 5 Pascal. What is the total pressure? So total pressure, P total, is equals to 10 raised to the power 5 Pascal. Okay. And iodine vapor contains 40% iodine atoms. Okay. So in this equation, this atoms, 40%, this iodine atoms, kitne 40%, right? So here iodine vapors is being converting into 40% iodine atoms. It means that the leftover, okay, it's 40% iodine atoms bun rahe hain, so 100%, 100 total 100% is present. So in the 100%, 40% is iodine atoms. So the remaining will be the iodine molecules, right? In 60% iodine atoms will be there, right? So 60% iodine I2, okay, I2 atoms. First of all, let's understand this equation because this is a equilibrium equation, right? So it must be a forward equation, forward reaction bhi ho raha hai, and at the same time backward reaction is happening, right? So this I2 is being converted into a 2 moles of iodine atoms, which is 40%. I2 is being converted into a 40% iodine atoms, right? And this iodine atoms is being converted into a 60% I2 molecules. I2 molecule, right? Now, and total pressure is this much. Okay, we have to calculate the Kp for the equilibrium. Okay, now see, first we will calculate the partial pressure because when I just told you in the previous class, whenever all the species are in gaseous form, in a reaction, when all the species like reactant and product, all the species are in gaseous form. So we will talk about the Kp constant. Okay, your Kp, we will talk about the Kp, not Kc. Okay, we will not talk about the Kc, we will talk about the Kp. So we will talk about the pressure, right? Pressure of the gases. So that's why the pressure has been mentioned over here. So partial pressure of iodine atoms is equals to. So here it has been mentioned in this question that iodine vapors contains 40% iodine atoms. So total pressure is given. So partial pressure क्या हो जाएगा? Partial pressure is the 40% of your P total. Okay, what is partial pressure of iodine atom? So it is the 40% of the total pressure, right? Now you can calculate the 40%. Okay, you know very well how to calculate this. 40 upon 100, right? Percent sign 100 multiplied by P total. What is P total? P total is 10 raised to the power 5 Pascal, right? So it will become 0 will cancel out and it will become 0.4 multiplied by 10 raised to the power 5 Pascal. So that is the partial pressure of iodine atoms. Now similarly, you can also calculate the partial pressure of I2, okay, the iodine molecule. Just quickly solve this. What is the partial pressure of iodine molecules? It's 60% of the P total, right? 60% of the P total. Partial pressure What it will, so it will be 60% of your P total. It means 60 upon 100 multiplied by what is P total? 10 raised to the power 5 Pascal. So 0, 0 cancel. It will become 0.6 into 10 raised to the power 5 Pascal. Okay. Now we have partial pressure of iodine as well as the partial pressure of iodine atoms. Okay. Now just write down the Kp equation. What will be the Kp equation? Kp is equals to the, now why we have calculated the partial pressure? Because as I told you, in a reaction, if the gases are given, so we will write Kp and we will talk about the pressure instead of concentration. Okay, we will not take the concentration. Instead of concentration, we will talk about the pressure. So that's why I have calculated the pressure in this question. So Kp will be equals to, this is the equation, this is the reaction. I2, okay, and the product is 2 iodine, okay, iodine atom. So in the numerator part, we will write the product side, okay, the pressure of, not concentration. I will not write the concentration symbol over here. I will only write the pressure, okay, the pressure of iodine, okay, pressure of iodine. And this is the stoichiometric coefficient, so I will write it as a power, raised to the power 2 upon. Now, what is reactant? So, reactant is I2, pressure of I2, right? Here, there is no coefficient, okay, 1, so no need to write it. Now, we have the partial pressure, just substitute the value. Pressure of iodine is 0.4 into 10 raised to the power 5 square. Okay, and you will also write down the unit. So it will be Pascal and square. Pressure ka square means unit ka bhi square aap karoge. So it will be Pascal square. Now, upon your pressure of iodine, I2. So it will be 0.6 into 10 raised to the power 5. Okay, there is no power over here into Pascal only. Okay, now just cancel. Something will cancel it out. So basically, we will write 0. Just multiplied 0.4 into 0.4. Okay, and it will become, when you multiply the power, so what it will become? 10 raised to the power 5 into 10 raised to the power. Okay, so it's a square. That's why I have written like that. Okay, 2 times Pascal square. Okay, this Pascal and 1 Pascal will cancel out. 10 raised to the power 5, 10 raised to the power will cancel out. Now, this will become, okay, so it will become 0. Let's just cut it using the 2 table. 0.2, 2 2s are 4, and 2 3s are 6. Right, so it will become 0.4 into 0.8. It will become 0.08. Okay, and in the numerator denominator part, it will be 0.3 multiplied by 10 raised to the power 5. Okay, now see. So this will become, so 0.8. Okay, so can we write 0.10 raised to the power 5 as 0.08 into 10 into 10 raised to the power 4? Yes, we can. 10 raised to the 5 को हम क्या लिख सकते हैं? 10 raised to the power 4 into 10 raised to the power 1 upon 0.3. And this will become, when you multiply this, it will become 0.8 upon 0.3. So this decimal and this decimal will cancel each other, and you will get 8 upon 3. 8 upon 3 multiplied by 10 raised to the power 4. Okay, now 8 divided by 3. Okay, so it will become 3 2s are 6. Okay, 3 2s are 6, and okay, so 6 and 7. 2.67 multiplied by 10 raised to the power 4 Pascal. That is your final answer. What is Kp? Kp is 2.367 into 10 raised to the power 4 Pascal. And you can also write the approximate value, 2.7 into 10 raised to the power 4 Pascal. Clear to everyone this question?
Yeah, ma'am.
Yes, ma'am.
Yes.
Okay, now you can write it down.
Can you also show the question 1 second? Okay, we can start.
Okay, done.
Yeah.
Now see. Okay, is this thing you have to keep in your mind. The concentration of pure solid and pure liquid is taken as unity. Okay, so that's why you have done this mistake. Okay, I just basically ये point मैं भूल गई थी आपको बताना, so that's why you have done the mistake in your homework. So concentration of pure solid and pure liquid, we just take as a unity. The concentration of pure solid and pure liquid is 1. Okay, now see. So I have given you this homework. This was your homework. And both only Neha and Aman have submitted their homework and they have made the mistake due to this point. Okay, so now let's discuss it over here. So question is write the expression for the equilibrium constant Kc for each of the following reaction. Right, so let's write it down. For the first one, what is the Kc? What is the equilibrium equation? Kc will be equals to, so we just write down the product first, concentration of NO, okay, raised to the power 2, concentration of Cl2 raised to the power, there is no power, okay, there is no coefficient, upon the concentration of reactant, which is NOCl raised to the power 2, right? That is the equilibrium equation, the expression, equilibrium expression. Okay, just quickly do the rest of the question. Second, third, fourth, and fifth. But keep in your mind that the pure solid and pure liquid, the we just take the concentration as unit 1. Okay, so let's not waste much time. Second question, C. So here you can see CuNO3 whole twice, right? CuNO3 whole twice. It will dissociate to form copper oxide, NO2, and O2 gas, right? Now you can see this is a pure solid, copper oxide, right? And this CuNO3 whole twice is again a solid, right? So you will take this as unit. Okay, so if the concentration is unity, so no need to write down in your equation. No need to write down in your equation because it will. So Kc will also will depend on these two concentration only. So you will write Kc is equals to the concentration of NO2 raised to the power 4, okay, multiplied by concentration of O2 raised to the power, okay, there is no coefficient, so no need to write down the power. So that is the equilibrium expression for the second equation. Okay, so basically the pure solid and pure liquid concentration is taken as unity. Always keep this in your mind. For the third, for the third reaction, CH3COO. See, this is an aqueous, so you will consider this. But this H2O, it's a liquid, pure liquid. So you will take this as a unity. So you will not write this expression, the concentration of H2O in your equilibrium expression. So what will be the equilibrium expression? Kc is equals to the concentration of CH3 COOH, right? Multiplied by concentration of C2H5OH upon this one, the concentration of CH3COO C2H5. Clear to everyone?
Yeah, ma'am.
Yes, ma'am.
Okay, do the rest of this question, fourth and fifth. Okay, if in the see fifth question, if the state is not given, so you will consider the concentration in your reaction. If the state is not given, right? So in the bracket, it is not given whether it's a solid, liquid, or gas or aqueous. So you will consider its concentration in the equilibrium expression, right? Now for the fourth one, yes, Aisha, tell me the equilibrium expression for the fourth question.
Ma'am, we consider FeOH, the whole three as unity, right?
Yes, yes. So tell me the final expression.
So it will be 1 by Fe3 plus the concentration
Hmm.
into OH minus raised to the power 3.
Yes, good. Okay, the next fifth one. Yes, Zanab, tell me. What is the equilibrium expression for the fifth one? Yes, Zanab. Try this. It's very simple. No? Yes, Zunaira. Yes, Zunaira, tell me the fifth one. Fifth answer. If you are not getting my point, then please ask your doubt. Yes, Aman. Aman has done this correctly, right? You have submitted your homework. So I think your this topic is clear to
Uh,
you.
it's IF5 raised to 2 by
Yes, Kc is equals to IF5 raised to the power 2
2
upon.
upon I2 into F2 raised to 5.
You're not getting my point. I think you have submitted your homework, and in your homework, I think आपने ये correct किया. And now you are just
Okay,
telling me
let
the
me check.
wrong answer. Now you are telling me the wrong answer. Why? I just told you for
Oh,
the
yeah, it's
pure
only
solid,
F2 by 5.
yes, right? Concentration of F2 raised to the power 5. This will be, you will not consider the concentration of I2 because it's a pure solid. Okay, as I told you, the pure solid concentration is always taken as unity. Now, clear to everyone?
Yeah, ma'am.
Yeah, ma'am.
Okay. Okay, now let's move to the next topic. Yeah, one more question. I just gave you in your homework. Okay, I'm discussing it over here. Second question. So in this question, again, you have to write down. It's not mentioned that you have to write down the KC or KP. Okay. Accordingly, you will write down where you have to take the KC and where you have to write down the KP. Right? I will tell you where you have to write down the KC or KP. So question is write equilibrium constant expression. First question was BaCO3, which is in solid form, CO2. Second, try to write down the question along with me, okay, and also write down the answer. Okay, these six questions I have given in your homework. So you have to write down the equilibrium constant expression. Okay, and I will tell you in which expression you will take the Kc, you will write Kc equation, and in which expression you will write down the Kp. Okay, so let's discuss one by one. Okay, quickly note down the question first. Written the question, everyone?
No, ma'am. One second.
Okay. Okay, so let's discuss one by one. First question was BaCO3. Okay, so here BaCO3. Right. Now see what I said. For the pure solid and for the pure liquid, the concentration becomes your unity, right? So you will not consider this and this in your equilibrium equation, right? So you will consider they will be unity. Okay. Now see. So when you're not considering this because these are pure solid, so you will consider only this carbon dioxide, which is in gaseous phase, right? So if you are considering accepting this one, this BaCO3 and BaO, they are solid, right? So you are only the reaction constant, the constant, the K, the reaction equilibrium constant will only depend on this CO2, right, which is in gaseous phase. So if it is in gaseous phase, only one product is there, and that product is in gaseous phase. So you will use Kp for that. Okay, so in your equilibrium constant expression, you will write Kp is equals to, and if you are using the Kp and it's a gas, so we will talk about the pressure of this carbon dioxide. Okay, because it's a gas, so we will talk about the pressure. So you will write P of carbon dioxide. So that is the equation. Kp is equals to pressure of carbon dioxide. Clear to everyone?
Yes.
Yeah, ma'am.
Yeah, mom.
Now see for the second one. For the second one, let's chalk it away. This is AgBr. Okay, this is again in solid. So you will take it as a unity. So Kp, so it is an aqueous phase and aqueous phase. It is not in the gaseous phase. So you will use Kc for that, right? So Kc will be equals to the concentration. And if you are taking the Kc, you will talk about the concentration, not the pressure, right? Pressure हम किस में बात करते हैं? When the reactant or product, anything which is in gaseous phase. Okay, all the species, it is in gaseous phase, so we will talk about the pressure. Okay, and if you are talking about the pressure, you will consider the Kp, not Kc. Okay, so in the second equation, because all are in the aqueous phase, so you will consider writing Kc. Kc is equals to concentration of Ag plus, okay, into concentration of Br minus. That is the expression. You can check it out, right? Ag plus and Br minus. There is no coefficient over here, so no need to write on the power. Next question, question number C. Okay, now this is in gaseous phase, right? And this you can check over here, CH3, COCH3, which is in liquid, right? So for the pure liquid, you will consider it as unity. You will take the concentration of this as unity. Now, so we are not considering this. So which one is left? This one, CH3, COCH3, which is a product, which is in gaseous phase. So you will write Kp for that. You will write Kp is equals to the pressure of CH3, COCH3. Why? Because CH3, COCH3 is in gaseous phase. Now, is it correct? Is it clear to everyone? B and C,
Yeah, mom.
where we will take the Kp, where we will write down the Kc, where we use the pressure, where we use the concentration. Okay, अब समझ आ रहा है? Clear हो रहा है doubt? Everyone?
Yes.
Yes, ma'am.
Okay. Now see the D. Question number D. See this. Okay, now it's in gaseous, methane is in gaseous phase, O2 is in gaseous phase. Now this carbon dioxide is in gaseous phase, but this H2O is a liquid, pure liquid. So you will take this as unity, right? Now, so now you can check all are in gaseous phase. So which term we will use? Kp. We will use Kp for that. And you will write pressure of pressure of your carbon dioxide, which is the product side, okay, upon the pressure of CH4, okay, multiplied by the pressure of O2 raised to the power 2. You can check the equation. O2 raised to the power 2. Now, this is for the E. Now see the E1, E part. Okay, so this is aluminium. Again, this is a solid. So you will take this as a unity. This is aqueous, this is aqueous, this is gaseous, right? Now here, this reactant is in aqueous phase, but this Al3 plus is in aqueous and it is in gaseous phase. Okay, so you will not write Kp for that. Kp, we use Kp in that equation where all the species are in gaseous phase. Just remember that. Here, only one species, which is H2, is in gaseous phase, but the remaining one is in aqueous phase. So you will not consider writing the Kp, right? So you will write Kc for that. Kp हम तभी use करते हैं when all the species are in gaseous phase and we will take the pressure of that. Okay, we will take the pressure of all the gases. But if all the species are not in the gaseous phase, so you will write Ac for that. Ac will be equals to, what is this? Al3 plus Al3 plus concentration of H2 and raised to the power 3 upon 2. Raised to the power 3 upon 2 upon. Okay, on the reactant side, only H plus ion is there. Okay, 3H plus ion. 3H plus ion. So you will write concentration of H plus ion raised to the power 3. Raised to the power 3. So that is your equation. E1 is clear?
Yes.
Let's see the
Yeah,
last
ma'am.
one. HPO4 2 minus. This is an aqueous phase, right? This is the water, right? Aqueous phase. This is your water. Basically, it's in liquid form, right? H3 hydronium ion, which is an aqueous phase. This is an aqueous phase. So you will take this as a unity for water and you will write, and we will consider because all the species are in aqueous phase, right? So you will consider writing Kc is equals to the concentration of hydronium ion multiplied by the concentration of PO4 3 minus upon PO4 2 minus upon the concentration of HPO4 2 minus. Okay, so that's how we just write down the equilibrium constant expression. Now you guys are able to write any type of equilibrium expression using the reaction. From the reaction, can you write down?
Yes.
Any doubt, anyone? Just please clear your doubt now. Okay, now just quickly note it down. And everyone, please submit your homework before the next class. Written, everyone?
Yeah, ma'am.
Yes, ma'am.
Okay. Okay, so I stop this session here. And in the next class, we will discuss some more questions. We will discuss some more topic. Okay, but for that, please revise your notes regularly on a regular basis, please. It's a request to all of you. And please try to submit your homework just after revising. See, after the class, whenever you got the time, it will take only 10 to 15 minutes to revise one chapter or your one class notes. Just revise the notes, just go through that, and after that, just complete your homework. Okay? When you revise a topic and after that you attempt the question, so it will be very easy and it will be very helpful to solve the question. You will be able to solve the question. Okay? And if there's any doubt, you can ask me in the next class. And please try to submit your homework before the next class so I could get to know whether you are getting the point or not, you are able to solve the question or not. So that accordingly, I will change my teaching methodology and so on. Clear to everyone from today's class? Any doubt?
No, mom, no doubt.
No.
Neha, clear बच्चे? Why are you silent today? Are you there, Neha? No response. Aman, is it clear? Any doubt, Aman?
No much.
Zunaira?
No, ma'am.
Zainab?
No, no.